Oh, good. Now, welcome back to class. Thank you. Welcome back to Mathematics with Edu Ada. So, quickly, you also want to make my appreciation known for support. Your subscribing to my channel is such a pleasure. Thank you very, very much. And for your feedbacks, I will also be expecting them. So, quickly, today we're talking about meaning and measurements of angles. We're dealing with measurement of angles. We started with that with the geometry 1 and 2. But now we are going to be considering angles between parallel lines. There are so many angles between parallel lines that you need to be aware of and how to measure them, how to make use of them when you are doing with anything in geometry. In mathematics, the use of geometry spans through a lot of aspects of mathematics. So you must be able to maneuver through these angles. First, we consider alternate angles. There are alternate interior angles and there are alternate exterior angles. But first, let's consider the interior one. Now, we have alternate interior angles are interior between the parallel lines and they are alternate sides of the transversal. Now, this is what the transversal line is talking about. Let me draw something. So you have something like this. So probably I make this known first. So each time you look at this sign between two lines or on a line and the other line is there, even just a line, this shows this is a sign of parallelism. It means these two lines are parallel. What if you now have a line drawn across the two? This is a transversal line. It is a transversal line. So you have this to be transversal. Then you have the two horizontal lines to be parallel to each other. So where do we have an alternate angle? Yes, you can as well call an alternate angle a Z angle, because with you being able to see the Z in the geometry, you will automatically be able to identify the alternate angles. Let me show you something. You have this, you have this, you have this, you have this. I don't know if you can see the Z. This is the Z I'm talking about. This is the Z. Can you see the direction? So where are they alternating? Look at this. Look at where they are alternating. So I can call this A. I can call this B. But A will be equal to B. Why? Because they are alternate angles. Let me show you from the note I have on my board. Look at this. You're told when the lines are parallel. Okay, let's go from here. Notice that they are not adjacent, of course. Adjacent angles like 2 and 4, they are adjacent. 3 and 1, they are adjacent. But these ones, alternate angles, are not adjacent. Look at this one written in red pen. You have 1 and 2 to be alternate angles, and you have 3 and 4 to be alternate angles. So angle 1 and 2 are alternate interior angles, and 3 and 4 also alternate interior angles. If you draw Z on the diagram, the alternate interior angles can be found in the corners of the Z. In the corners of the Z, I've illustrated that up in the corners of the Z. Okay, where are the corners? Okay, let me still use my example here. This is Z. So this is a Z. Can you see the Z? So this is Z. In the corners of the Z. So this is the corner they are talking about. This corner is equal to this corner. So this angle is alternate to this. Alternate. This corner is equal to this corner. So this angle is alternate to this, and they are equal. So alternate angles are equal. So what sort of exterior alternate angles? If you draw it, okay, you have this, you have this. I've shown that if two parallel lines are cut by a transversal, the alternate interior angles are congruent. Congruency means equality. If two lines are cut by a transversal and the alternate interior angles are congruent, the lines are parallel. So these are theorems in geometry that all math students should be familiar with. Now let's consider alternate exterior angles. The word alternate means alternating sides of the transversal. The name clearly describes the location of the angles. When the lines are parallel, the measures are equal. When the lines are parallel, the measures will definitely be equal. Okay, let's just quickly look at that of the alternate exterior angles. I can still construct that for you. If you have something like this, so all I have to do here is to show you that I've drawn a Z anyway, but I can just tell you it's a straight line I drew. Yes, there is a straight line. So by just extending the points of the Z, the extreme end of the Z, by broken lines, and then I had what? These parallel lines. Can you see this? So this, now we spoke about this place, this angle and this angle to be interior alternate angles. What of the exterior that we have? So if you have exterior, let me extend this line. Let me extend this. Permit me to extend it this way. Have this way. So what do we have? I'm coming back to this pen. So what do we do? Instead of picking this angle and this angle as exterior interior alternate angles, all you have to do is what? Pick those at the end. Like I normally tell my student, this place I take it as an open angle. This place is a closed angle because there's a line that's closing it at the top. So you don't pick that place, you don't pick that place, you don't pick that place, you don't pick that place. What you pick, you don't pick this place too. What do you pick? You pick this place. This is an exterior, this is also an exterior, and they are on the same line. Note that if this exterior alternate angle is similar to corresponding angles, but I will show you the only difference when I get corresponding angles. So you have this side. If I name this A, this is B. A is equal to B. You get that? So those are exterior alternate angles. So if you continue, you have this, congruent corresponding angles. Okay, I think I mentioned this. If two parallel lines cross a transversal line, the alternate angles are congruent. So we've said that before. Then corresponding angles. Let me illustrate that with this. Okay, let me first mention that here 1 and 2 are corresponding, 1 and 2, 3 and 4 are corresponding, 5 and 6 are corresponding, 8 and 7 are corresponding. Let me illustrate that on the one I drew before. I made mention of it the other time, that if you observe that A and B and A, they are on the same transversal line and the same side of the transversal line. But if you now choose to say, okay, I'm not putting the angle here, I want to put the angle here, this shows that this angle is transversal to this. Me personally, I say it is a closed and an open angle that gives us corresponding angles. For example, if you are working under circuit geometry, you are working under alternate angles of elevation and depression, you need this knowledge to work through that. So you need, once you see an angle between two parallel lines, you can be the one to construct the parallel lines yourself. Provided you are able to construct it perfectly, it gives you two parallel lines, and the angles between them, they look of this form, so that one is in, another one is out, they are corresponding angle. Which other corresponding angles do we have here? This one is in, yes or no? So we can come and pick this one. I can call this C, I can call this D. C and D, they are corresponding and they are equal. Corresponding angles are equal, I can pick another angle here. I decide to pick another angle here. Look at this place, and I pick this place. This is close because this one is closing it. I can call this F. I can call this G. F and G, they are corresponding angles. Please, do we get that? Good. I believe you are following me and you are getting the concept. You can always, pause the video and watch again to get a better understanding of what I've illustrated. So that is that about alternate angles. Okay, let's talk about interior angle on the same side of the transversal. This is what it means. Interior angles on the same side of the transversal, they will be supplementary. What are supplementary angles? Let me first illustrate with this. If you have angle, everybody knows, we all know that angle on a straight line will give us 180. Yes, it is angle on a straight line, isn't it? Good. So if you have any angle form on this, you have this drawn, and you have this, you have this to be A, you have this to be B. A and B, they are supplementary angles. They add up to 180 degrees. But if you have two angles that are on the same side of the transversal line, or between two parallel lines on the transversal line, and they are on the same side, I will call them at times facing angle. Look at this. Okay, let me illustrate with this. Let me wipe this. Just follow me. So this A and B will add up to 180. If you now have it in this form, have this. You now have this. This angle, they are on the is on the transversal line. This angle is on the transversal line. So I can have G here. I can have H here. Do you know these angles are actually supplementary angles? We call them interior angles on the same side of the transversal. So which means this one too, if it's on this other side of the transversal, I have another one here. These two, they are equal. That is why you can have a question in your exam given in this form. Permit me to correct this side. Oh, you can have a question in your exam to be given in this form. Yes, you'll be given this, you'll be given this. You can be given this as 80. You'll be told to find X. This 80 and X is the same thing as H and G. They are supplementary angles in the sense that they are on the same side of a transversal. This is a transversal line to these two. These two lines, they are parallel. This guy is parallel to this. Is that good? I want to be sure, or I'm sure already that you are getting what we are doing. So that's for interior angles on the same side of the transversal line. I appreciate you for your time. Yes, I really appreciate you for your time. So we are going to stop this video here, but in case you need our assistance, you need a service to teach you either online or physical class, we are always available. Yes, so you can reach me on this line. You have 081 64 86 9470. Thank you. Till we see again, remain blessed.